Hello, welcome to the notes, 9.4, similarity in right triangles. The situation that we have here is that we have a right triangle that then has an altitude drawn, which creates three total similar right triangles. So I've got the static image there on your left. I'm going to draw another picture here to kind of walk us through as we go here. So I have a right triangle, right, this purple triangle here, and I am calling this purple triangle ABC. And when I take and I draw the altitude from the right angle straight down, it creates another right angle to the hypotenuse. And from there, what I've done is I've created two right triangles inside the existing right triangle. So here's A. We're going to call this point D. This is C. This is a right angle here. And then right next to that, I've got this green triangle also. Okay. Now in my image here, I have similarity statements. And those similarity statements describe a triangle similar to another triangle. But when we do this, they have to go in, the letters have to be in corresponding order. So when writing similarity statements, the letters must be in corresponding order. So let's check this out. This first triangle ABC, I'm just going to name it in alphabetical order. Now when I want to write a similarity statement between the purple triangle and the blue triangle, I want to know what angle in the blue triangle corresponds to angle A in the purple triangle. So I have angle A here. Hopefully you would agree that angle A in the blue triangle is the same because they are actually the same angle, right? You have to imagine that the blue triangle is inside the purple triangle. So A is going to go to the first one in the first spot. Now I also know that triangle in the purple triangle, triangle C is a right angle. And right here in my blue triangle, triangle D is a right angle. So I know that those correspond. Then I have to find out what angle corresponds to B. Well, now in a triangle, if I have two angles in a triangle are congruent to two angles in another triangle, then it's automatic that the third angle is congruent because all triangles have to add up to 180 degrees. This tells me that angle B, the third side in the purple triangle, the third angle in the purple triangle, excuse me, must be congruent to angle C, which is the third angle in the blue triangle. So I have this similarity statement. I'm going to keep moving with this logic. Okay, in the green triangle, all right, let's try to find what order I can write this in for my similarity statement. So order matters. In the purple triangle, I have angle A, triangle ABC. Let's go through. I'm going to use my pointer here. Angle B in the purple triangle is going to be the same as angle B in the green triangle. They're on top of each other, right? I have my right angle D, which corresponds to my right angle for C, which means that if I have two angles that are congruent in the purple triangle, then I have two angles that are congruent in the green triangle, then the third angles must be congruent. So that means A is the same as C. So when I state the green triangle, I'm going to have C first, because it corresponds to A. Then I'm going to have B. And then I'm going to have D. It has to go in this order. They have to be listed in corresponding order. So here's a different way to write a similarity statement. Above, I only have two triangles that are similar, and I wrote all the combinations. And then here, I've just got it written differently, but I've got one statement with them all being similar. Just different ways to write similarity statements. So when I take a right triangle and I draw an altitude from the right angle, in fact, this triangle here should have a right angle. Let's see, this one. We can come up with all kinds of proportions in this triangle because now I have three similar triangles. And we know that similar triangles mean that angles are congruent and sides are proportional. So I'm going to read through and kind of go over all this jargon and geometry, and then I'm going to give you a memory device after we talk about the altitude rule of a right triangle and the leg rule of a right triangle. The first one's a little bit easier to understand. The altitude rule for a right triangle says the length of the altitude, so in this question that's x, is the geometric mean of the length of the two segments of the hypotenuse. All right, let's talk about geometric mean really quick. Oftentimes when we think about mean, we are talking about arithmetic mean. An arithmetic mean is when I add two numbers together and divide by 2, it's taking the average. When we're talking about geometric mean is when I multiply those two numbers together and take the square root. So the proportion is going to look like this. If I'm talking about x is a geometric mean of m and n, then that's going to look like m is proportional to x as x is proportional to n. And this is what we're going to be setting up here. So when I crisscross multiply this, I have m times n equals x squared. Coming back to my rule, the length of the altitude x is the geometric mean between the two segments of the hypotenuse. So the segment's going to be A and B. So you'll see here how I have this set up. Part of the hypotenuse over x is equal to x over the other part of the hypotenuse. This one's a little bit more complicated. The leg rule for a right triangle. So remember that adjacent means next to. So for example, my classroom is H105, which means I am adjacent to classroom H104. Okay. So each leg, let's start with just any leg. Each leg, like B, is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to the leg. Now the length of the entire hypotenuse here, let's see, if I just assign some numbers to these to make this more relevant, if I said D was 10 and C was 5, then to find the whole length, you would do 10 plus 5 and get 15. To keep the abstract here, I'm just going to do D plus C is the length of the hypotenuse. So this says the leg of the large triangle, like B, is the geometric mean of the entire hypotenuse and the piece of the hypotenuse adjacent to the leg. Okay. Conversely, if I was talking about the other leg, all right, if I was talking about this leg A, this other leg is the geometric mean between the length of the entire hypotenuse and the part of the hypotenuse that's adjacent to the leg. So I'm going to have you write down a couple of notes here for these that are going to make sense as we go. If I need to use the altitude or I'm asked to find the altitude, I'm going to use this rule called the altitude rule for right triangle or taking the elevator. And you can start from either side when you do this, it doesn't matter. And that'll make more sense when we look at it in more detail. Sorry, I have some errors here. Okay, start at the acute angle across from the leg. Okay, great. So these examples are going to be a little redundant. I'm going to make sure that I go really slow through the first one, and then it might speed up as we go. Actually, before we get into that, I do want to show you this animation. So one of my team members, another teacher that I have the pleasure of working with, created this animation to show you what does it look like to apply these rules and to kind of go with these memory devices that we call taking the elevator or walking the dog. So this animation I'm going to pull up. I'm going to kind of talk you through it as it plays. And it just showcases what's happening here. So there's a soundtrack here of this artist who sings a song called Walking the Dog. He's a jazz artist from the 60s. It's a little fuzzy, so I'm gonna talk through this animation instead. So the first thing we're going to do is we are going to do this rule called walk the dog. So here's the dog over here by angle B. And as the dog follows a path, we're going to fill in the lengths into this proportion. So the dog's going to cross the entire length of the hypotenuse, which is length AB or VA. The dog's going to travel up this hill, which is length AB. So fill that into the proportion, come back down the hill, and then comes back and stops at the right angle there. So I know that AC and CA look different, but remember that those are the same thing. So when I go back and talk about the rule says that the leg, AC, is the geometric mean between the entire length of the hypotenuse and the piece of the hypotenuse adjacent to the leg. Okay. It's going to do it again from the other side, just to really drive this point home. Okay, so now it's starting from the other side. So the dog's going to walk the entire length of the hypotenuse again, which is the length AB. So I'm going to put that on the top left-hand side of my proportion. Goes up the hill and comes back down the hill. Those are the same lengths, all right, and should be here on the geometric mean on this diagonal. Then he returns and he comes back, but he stops at the square. So whatever this length is that's closest to the leg wanted. So if you can kind of remember the story, then you can kind of help remember the theorem and how to set it up. Now this is this is the first rule that we talked about. Now I don't have, this time I'm working with the altitude and the right triangle. So another proportion down here, here we go. So this person walks into a building, say, and then goes into the elevator. So into the building, up the elevator, back down the elevator, and then the person goes out the opposite door. So we were joking that, you know, if he goes in one door, he's got to go out the opposite door, kind of like how buildings and hallways now are one direction during the pandemic. So something to consider. A story that we have now that we didn't have before. All right. So now through example 1, the problem asks us to find PS. So PS is this part of the hypotenuse here. I'm going to choose a letter to represent PS. And I'm going to choose X because that's what I've trained to use as a math teacher. All right. I don't have any information about the altitude. I'm not looking for it, and I am not given it, so I know that I'm not taking the elevator. I'm going to walk the dog. Technically, on this problem, because I have both legs, I could walk the dog from either end. It's going to be easier if I start at P. So you can still do it from the other side, all right? And this isn't something you'd be able to recognize until you've had some practice here, but it's going to be easiest to walk the dog from P. So I'm going to set up my proportion. So I walk the dog all the way over the whole length of the triangle. And that length, I have X and I have 9. So that whole length is going to be X plus 9. I walk up the hill, which is 15. The story continues that I walk back down the same hill, which is 15. And then I start my way back, but I stop at the right angle here. So that length is 9. That's what that new rule says. I'm going to solve this proportion by cross multiplying. Whenever I have an expression in my fractions here, I definitely need to put it in parentheses. Because when I cross multiply, I have 9 times x plus 9 in parentheses, and then is equal to 15 times 15. I distribute. 9 times x is 9x. 9 times 9 is 81. 15 times 15 gives me 225. Subtract 81 from both sides. And divide by 9. This gives me a result of x is equal to 19. I'm sorry, x is equal to 16. It didn't ask me for x, it asked me for PS, so I need to make sure I answer appropriately. I labeled PS as x, so they are going to be the same number. My answer will be PS is equal to 16. The next problem asks me to find QS. QS is the altitude. I'm going to go ahead and call that Y. Now you have some options here. You could redraw this triangle to write all over it. You could erase what has already been written and reuse it. Or you could, I'm just going to, that didn't work how I wanted it to. I'm going to redraw by copying my triangle. All right, benefits of being digital. Otherwise, you can just erase and draw on the same picture or use another color to make it stand out. Now I'm looking for Y, but I already found that PS is 16. This is the same picture, so my conditions haven't changed. Now I'm just looking for a different part of my triangle. I just took another picture here so that I could write on here, and hopefully you can have clarity on what I do to set up the next problem. So when I want to find Y or use Y, I'm going to use take the elevator. And when I take the elevator, it does not matter what side I start from. Inconsequential. So if I start at P again, I walk in the door of this pyramid-shaped building and come over to the elevators. The length of that is 16. I take the elevator up to the top, which is the length Y. Maybe I check out the view, do some sightseeing. I take the elevator back down. That length is Y. And then I'm not going to go back out the same way I came in. I'm going to go out the opposite door, which is 9. This says that the altitude is the geometric mean for the two pieces of the hypotenuse. I crisscross multiply and have 16 times 9 is equal to Y times Y. 16 times 9 gives me a 144 equals Y squared. To get Y by itself, I take the square root of both sides. When I take the square root of both sides of an equation, I get positive and negative, in this case 12. All right, but I didn't want Y. I want QS. Please don't say that the answer for QS is positive and negative 12. We are talking about a length of a triangle here, and length must be positive. Distance, length must be positive. So this is going to be just good old 12. Now in the original directions, you may have noticed that it says to leave answers in simplified radicals. What it's looking for here are exact answers. Not rounded. But since radicals weren't necessary, then you can just leave it as those good old whole numbers there. When you look at the next example set, you'll see that these are in decimal form. And decimals could be terminating or rounded decimals. Okay, so example 2, very similar type of problem. It gives me different kinds of information. This time it gives me both pieces of the large hypotenuse. And it says find CD. So I'm going to use a different letter this time. Try to get away from the X and Y. I'm going to call this N. Now I know this triangle is oriented differently than we saw last time. And if you have this on a piece of paper, you could turn your piece of paper upside down and work that way. Since mine's on a screen, I'm going to work with it just how it is. This is still an altitude. So I know that when I want to find an altitude, I am going to take the elevator. Now, for how my picture is oriented now, I'll actually be taking the elevator down, but that's totally cool. It'll still work. It does not matter which side I start on. So I come into the building. Since I started at point B, my length into the building is going to be 3.6. Then I take the elevator down to the basement. Maybe I'm checking out some archives, or I don't know, got some cool bunker down there. Then I come back up the length of the elevator, back up and then I'm going to go out the opposite exit of the building. You are going to want to use a calculator for this. So if you don't have one handy, pause the video and go grab one. It's going to be important that you practice with your calculator with me to make sure that your calculator's in the right mode and you know how to use it. When I multiply 3.6 and 6.4, I get 23.04. N times n is n squared. To get n by itself, we take the square root of the left and the square root of the right. The square root of 23.04 is going to give me positive n negative 4.8. Square root of n squared is n. I didn't ask for n, I asked for CD. So my answer is going to be CD is equal to 4.8, and I'm only going to put the positive answer. Now, this is okay for this to be in decimal form. Usually when I start in decimal, I will end in decimal. There's that. I have more work to do here, so I'm going to find BC. It's the same picture, I just copied it, so you could rewrite it down, or you could erase what you have on here and just draw on top of the same picture. Now I know that the altitude is 4.8. It's not going to do me any favors, but it's good to have all the information in one spot. And this problem's asking me to find BC. I'm going to call it K. I don't know, why not? Okay, so the rule, if I'm looking for a leg, then I need to use the walk the dog theorem, all right? The leg rule for right triangles. And that rule says that if I'm working with one of these legs, then I need to start on the angle opposite it. So I have to start over here with A. If you make a mistake and you start at B, as you start setting this up, you're going to notice, oh, I'm solving for AC. That's not what it asked for. So just check yourself. That's all. So I walk clear across the hypotenuse. What is that length? 6.4 and 3.6 is 10. This time I'm walking down a hill first. That length is K. Back up a hill, K. and then to this right angle mark, which is 3.6. When we crisscross multiply, I have 36 is equal to k squared. Square root both sides, and I find that k is positive and negative 6. When we write our final answer, we will eliminate negative 6 because I cannot have a negative distance or a negative length of a triangle. So this is just going to be positive 6. My directions said to leave in decimal form, but there is no decimal, so the whole number is perfect. Example 3. Example 3 is just more examples like A, B, and C, and example 4 is kind of the same thing. For example 3, I wanted to do this one because it asks to leave in simplified radicals, and we're going to get numbers that we have to take the square root of that are not perfect squares. So this is just an exercise kind of in that for that skill set. So A, find JL. I'm going to use some variable here. You don't have to use a variable. You could plug in JL for the whole thing. I choose not to. I like to have something simple. Now I have a leg. So this is going to be walk the dog. Which means I need to start opposite the side, so I have to start over here at K. I'm going to encourage you to pause this video and try to set up that proportion without my help. Ready, go. Okay, so this proportion here, I'm going to walk the entire length of the hypotenuse, which is 24. Walk down this hill, which is A, back up the hill, which is A, and then travel back to this right angle here, which is 4. Hopefully you're able to set that up on your own and maybe even solve it on your own. Or start to, that's fine too. We get 96 is equal to a squared. When I take the square root of the left and the square root of the right, I always get positive and negative, but 96 is not a perfect square. Okay, you might be tempted to plug that in your calculator, but this says to leave answers in simplified radicals. So I need to go back and use the factor tree, which we've reviewed a couple of times this year. And we can talk about what numbers multiply to 96. I'm just going to use 24 and 4 since those were the ones that were provided for me here. 4 is just 2 times 2. 2 times 2 again. And then 4 times 6. 6 is going to give me 2 times 3. Factor tree, I'm looking for pairs, right? Because I take the square root of perfect squares. 2 times 2 is 4, so I can take out a 2. 2 times 2 is 4, so I can take out a 2. And then I'm left with 2 times 3 on the inside. This leaves me with 4 square root 6. When I write my final answer, I'll write JL is equal to positive 4 square root 6. Now this is an exact answer, which is really nice. It's a little bit more difficult to understand like how big that is. It's 9 point something, but it's a little bit more difficult to kind of realize how long that is compared to like 4 and 20. All right. Find ML. So I'm going to ask that you give this setup a shot again. So pause the video, set this up, find ML on your own. just found that JL is 4 radical 6. And now I want to find ML, which is the altitude. Pause this and set up a proportion for the altitude. Ready, go. Okay, welcome back. You should have noticed that this is take the elevator, because I'm working with the altitude. So when I do that, it doesn't matter what side I start at. So if you started from K, that's great. We will get the same answer. Watch. I come into the building with a length of 4, take the elevator down, which is B, and then back up, which is B. Make sure that when you're doing geometric means for all of these problems, whatever is on the lower left and upper right are always going to match. That's the definition of a geometric mean, right? If I were to look up. And then out the other side is going to be 20. So I multiply 4 times 20 is equal to B times B. 4 times 20 is 80. B times B is B squared. 80 is not a perfect square. Guess what we need to do? Factor tree. Just pausing to give you a few seconds head start before I show you the correct answer. If you're watching me do the factor tree and this is kind of blowing your mind and you're confused or don't quite remember how to do this, you might want to look up maybe a refresher video, something on YouTube or Khan Academy on how to find the prime factors or how to factor whole numbers. Okay. By now, this should start feeling easy. This should be like second nature. All right. ML is equal to 4 square root 5. Now, there is another example on these notes. I am going to kind of just work out the solution and give it to you. So if you have this problem, what it's doing is it is saying that H is 30, so the length of this entire thing is 30, and S1 is 15. Find everything else. So I'm going to make a little key for myself over here. But I need to go through and find everything. Where you want to start is you want to start with S2. So the entire length of the hypotenuse is 30. S1 is 15. What does the other half have to be? That's going to be 15 also. All right. From there, you could choose to find U1, U2, or A first. It doesn't matter. You're just going to use different setups for each. I am going to encourage you to pause this video. In a few seconds, when you replay this video, the solution is just going to be posted without much of an explanation, right? Just for a practice problem for you. Please notice that it does say type exact answers, use radicals as needed, so there will be no decimals in these answers. Okay, ready? Go. Okay, here's the solution that I came up with. It doesn't matter which one you solve first. I went for A first. And when I solved it, I got 15. It's not a coincidence. I mean, it is a coincidence. It doesn't have to be the same, but that worked out. When I found one of the other legs, I found 15 square root 2. And then when I started setting up for the other leg, I noticed it was the exact same proportion. So I didn't want to spend my time solving that again. I knew it would be the same exact answer. So my answer key over here has got all of the pieces for this puzzle, left in radical form. All right, thanks very much, guys. Hope you have a good one. Take care.